What are the modes of encryption in block cipher? So they just tell how the blocks are going to be treated by the same block cipher. There are different modes, but in this tutorial we are going to look at only one of them, that is electronic codebook mode. So if we are given a message, we first split it into different blocks according to its size. The catch is that we do it by using the specific padding. We will not go into details of the padding in here, but we assume that the data is at the exact size after the padding, and we are able to split it into the blocks of equal size. Then we apply the block cipher and we get the respective encrypted blocks for each of them. Like we have encrypted the first block, we have encrypted the second block, and so on. We encrypt all of the remaining blocks. So this is a very simple mode of encryption, and it is a very basic mode of encryption. So now when we have received all of these 6 blocks, we just concatenate them and we get the encrypted message. We now understand the ECB mode by a practical example in Python language. So we create a new file and we name it as AES ECB.py. Now in this new file we first import our AES. So we write from crypto.cipher import AES, and then we import crypto.random import get random bytes. This function is to generate random bytes. Okay, now we initialize our cipher as AES dot new, and we will provide a key here. And now it is the important part that we are going to specify the mode. So we write AES dot mode and ECB. So this mode is the ECB mode. Now we need the key, so we generate the key from this random function. Key equal to get random bytes, and the size of key in AES is 16, so we get 16 random bytes as our key. Now we need our plaintext. So plaintext, we write here b hello world, and then we write encrypted text equal to cipher dot encrypt and plain text. Next we print our encrypted text. Now let us see if this is going to work. So we click on run without debugging, and if you see, there is some error. It is saying that the data must be aligned to the block boundary in ECB mode. What does it mean? So this implementation in the ECB mode doesn't have the padding of the data. So we need the data in the exact size, that is in multiple of 16 bytes. So what do we do now? Instead of giving it a particular text, we generate some random bytes. So we write plain text is equal to get random bytes, and we enter here the size 16. And now let us run this program. In the end we see that it has given us the output, and this is the ciphertext. Now as we discussed that in the ECB mode it treats every block as an individual block and encrypts it independently. So let us check if it is really so. So we write plain text equal to plain text plus plaintext and plus plaintext plus plaintext. So I have created 4 copies of the same text and concatenated it together. Now let us see what is its encryption. So we go to run without debugging, and we come here in this text. So if you see, the encrypted text is starting from xd5, and it is going to repeat after some time. So xd5, here it is again xd5, xb7, x92, and you can see that here it is the same xb7, x92, and then it is going to repeat itself again. It is here xd5, xb7, x92, and then one more time it will come xd5, xb7, and so on. So it shows that the ECB mode encrypts each and every block independently.